Good morning, everyone. This is Team TikTok represented by leader Chi Sen Yang, member Lim Go Hong, Go Siu Yan, Yap Su Chi, and Ling Kan Tak. Today we will talk about Module 2, Introduction about the Distributed System Concepts. This is the outline for the Module 2. The definition of distributed system. A distributed system is one in which components located at network computers communicate and coordinate their actions only by message passing. A collection of independent computers that appears to its users as a single coherent system. For example, Internet, intranet, emergency technology of networks based on mobile devices. A distributed system organized as middleware. Note that the middleware layer extends over multiple machines. The theory of distributed computing. Study of algorithms for sequential computers has generated a common framework for specifying algorithms and comparing their performance. The goal of distributed computing is to accomplish the same for distributed systems, but there are differences from sequential case. No single universally accepted model of computation. Different complexity measures time, space, communication, cost, number of faulty versus non-faulty components. The driving factors for distributed system. Ever-increasing need to share resources and information, more affordable, powerful workstation, widespread use of network, and maturity of software technology. The challenges in distributed systems. First, heterogeneity about the network, hardware, operating system, programming language, and implementation. Second, the openness about the system extension, re-implementation via standards, portability, interoperability, conformance to well-defined interfaces. Third, the security, confidentiality, integrity, and availability. And fourth, the scalability, the cost, performance, loss, and bottlenecks, resources, size, geography, and administrative scalability. Fifth, the failure handling, detect, mask tolerance, recover, and redundancy. Sixth, the concurrency, synchronization techniques. Seven, the transparency, perceived as a whole rather than a collection of independent components. And eight, the quality of service, reliability, security, performance, and adaptability. The goals of distributed system. First, efficiency, communication, load distribution, flexibility, users viewpoint, ease of use, consistency, reliability, system viewpoint, modularity, scalability, portability, interoperability. The robustness can handle exceptional situations and errors, changes in topology, long message delay, inability to locate servers, security, reliability, protection, and access control. Consistency. A system is consistent if there is uniformity in use the system and the system behavior is predictable. Integrity of the system must be maintained with proper concurrency control. Inconsistency can due to lack of global info, potential replication and partitioning of data, possibility of component failures, or complexity of interaction among modules.
Hi, I am Suchi. Now I will talk about the transparency in distributed system. It means that it hides all the irrelevant system-dependent details from the users whenever possible in a higher implementation complexities and trade-off simplicity and effectiveness. Access transparency means that it hides the differences in data representation, and how a resource is accessed. Location transparency enables the resources to be accessed without knowledge of their location. Concurrency transparency means that it enables several processes to operate concurrently using shared resources without interference between them. Replication transparency means that it enables multiple instances of resources to be used to increase the reliability and performance without knowledge of the replicates by users or application programmers. Failure transparency means that it enables the concealment of faults, allowing users and application programs to complete their tasks despite the failure of hardware or software components. Mobile or relocation transparency means it allows the movement of resources and clients within a system without affecting the operation of users or programs. Performance transparency allows the system to be reconfigured as loads vary. Scaling transparency allows the system and application to expand in scale without change to the system structure or the application algorithms. In this slide, we will discuss about the description of different transparency in a table form. In access transparency means that the description means that high differences in data replication and how a resource is accessed. Location transparency means it high where a resource is located. Migration transparency hide that a resource may move to another location. Relocation transparency hide that a resource may be moved to another location while in use. Replication transparency hide the existence of replicates and replicate management from users. Concurrency transparency hide that a resource may be shared by several competitive users. Failure transparency hide the failure and recovery of a resource, and persistent transparency hide whether a software resource is in a memory or in a disk. The diagram shows the software and hardware service layers in the distributed system. We include application, service, middleware, operating system, and computer and network hardware. Operating system and computer and network hardware is the platform. This slide shows the diagram of the hardware concept, where the shared memory and the private memory based on the bus space and switch space, where the different basic organization and memories in distributed computer system. The diagram shows the multiprocessor with a bus-based multiprocessor. Diagram A shows a crossbar switch, while diagram B shows an omega switching network. Diagram A shows the grid homogeneous multi-computer system, and diagram B shows hypercube homogeneous multi-computer system. The table shows an overview of DOS, NOS, and middleware. DOS stands for Distributed Operating System, NOS stands for Network Operating System. The main goal of DOS is to hide and manage the hardware resources, and the main goal of NOS is to offer local services to remote clients, and the main goal of middleware is to provide distribution transparency. The diagram shows the general structure of a distributed system as a middleware.
So this is leader speaking. For the middleware and openness, the picture shows that in an open world middleware-based distributed system, the protocol used by each middleware layer should be the same, as well as the interface they offer to the applications. So this is a table that shows the comparison between the different systems. The system, the Table show that a comparison between multi-processor operating system and multi-computer operating systems, network operating system, and also middleware-based distributed system. So for the service and concepts, there are three types, which is the primitive service, service by system and server. Last but not is the value-added service. Uh, s- for the primitive service, it is a fundamental function that the kernels might provide. And there are three minimum functions included, which is the communication, synchronization, and process serving, which manage the creation, deletion, and tracking of the processes. For the system servers, it provides fundamental services for managing processes, files, and process communication. Example, name server, directory server, network server, time server, file and print server, authentication server. Next, the value-added service. Services that are not essential in implement of a distributed system but are useful in supporting distributed applications. It is a high-level and spatial purpose services. Example, group servers to manage creation and termination of group activities. System model. All distributed systems share important underlying properties which give rise to common design problems. These common properties and design issues can be represented as the descriptive model, where each model is intended to provide an abstract, simplified, but consistent description of a relevant aspect of distributed system design. There are three types actually, which is physical model, architecture model, and also fundamental models. For physical models, it representation of underlying hardware elements of a distributed system that abstracts away from specific details of the computer and network technologies employed. It is a baseline physical model. Early distributed system is in 1970 to 1980. Internet scale distributed system is in 1990, and contemporary distributed system is now, uh, which is the mobile, ubiquitous, and cloud computing. The distributed system of a system is, for example, environment management system. Architecture model. It simplifies and abstracts the function of individual component of a distributed system and then consider the following: where to place the components across a network of computer in order to define useful patterns for the distribution of data and workload, the functional roles of components and the relationship between them, classify process into server process, client process, and peer process. For architecture model, define the way in which the components of systems interact with one another and the way in which they are mapped onto the underlying network of computers. It provides a high-level view of distribution function between components and the relationship combination pattern between them. Determines the distribution of data and the computational tasks amongst the physical nodes of the system. It is helpful when evaluating properties such as performance, reliability, and scalability. So this is a picture that shows the general interaction between the client and the server.
I'd like to introduce the first types of architecture model. As the image has shown below, the clients invoke individual servers and browsers and web server which uses a local file server. Then the second type of architecture model is a service provided by multiple servers and there's replicated web services. The third type of architecture model is there's a web proxy server and it provides a shared cache of web resources for client machines. A proxy server is a server that acts as an intermediary for requests from clients seeking resources from other servers. And the fourth type of architecture model is a distributed application based on peer processes. The variations on client-server model, the mobile code. A client request results in the downloading of applet code and The second one is the client interact with the applet. What is meant by applet? Applet is a small application which is written in Java and delivered to users in the form of bytecode. The mobile agents. Software agents are programs that exist people and act on their behalf. Mobile agent has the ability to transport itself from one system in a network to another. It's not bound to the network host where it begins the execution. A mobile agent is a running program, both data and code, that travels from one computer to another in a network carrying out a task on someone's behalf. Compared to static agents that make remote invocation to some resources, there is reduction in communication cost and time. The reasons for using mobile agents below are the advantages of using mobile agents. Some of it is reduced network load and client processing power, moving know-how to the data, overcome network latency, which is used in critical real-time systems such as robots, encapsulate protocols, which is working with proprietary protocols on remote hosts. And the last one is execute asynchronously and autonomously, which is independent of the creating host. Next, the mobile agents can adapt dynamically. It sense execution environment and react autonomously to changes. And the next thing is is naturally heterogeneous, which is the computer and transport layer is independent. It is also robust and fault tolerant. The mobile agent will react dynamically to unfavorable situations. The disadvantage of mobile agent is it is security risk introduced. A computer virus is some kind of MA, and MA may be attacked, modified, or deleted by hostile hosts. The spontaneous networking. Spontaneous networking is a distribution that integrates mobile devices such as personal digital assistant, mobile phones, and other devices. The key features for spontaneous networking is easy connection to local network, easy integration with local services. The issue is it has limited connectivity, security, and privacy. So here are the spontaneous network in a hotel which explained in the form of image.
Here is Limgo speaking. The next one is processing level. There are three levels, which is user interface level, processing level, and data level. The next one is multi-type architecture. There are five types of alternative client-server organization, and it consists of user interface, application, and database. This is the diagram of multi-architecture. The next one is the diagram of modern architecture. From the left is the front end handling incoming request, and the request is in round robin, and a replicated web server each containing the same web page in the disk. Fundamental model. Fundamental model is to provide a formal description of the properties that are common in all of the architecture model. The purpose of fundamental model is to specify the design issue, difficulties, and tricks that must be resolved in order to develop distributed systems that fulfill their tasks correctly, reliably, and securely. There are three key terms models, which is interaction model, failure, and security. Interaction model is composed of many processes interacting in complex way. Example, multiple server processes may cooperate with one another to provide a service, or a set of peer processes may cooperate to achieve a common goal. There are two significant factors that affecting interacting processes in DS. The first one is communication performance. The second one is maintaining a single global notion of time. There are also two variants of interaction model, which is synchronized system, which is bound on process execution time and message delivery time. The next one is asynchronous system, no bound imposed on process execution time and message delivery time. Second model is failure model. Failure model defines the way in which failure may occur in order to provide an understanding of the effect of failures. Classifies the failure of processes and basic communication channels in a distributed system. Omission failure. There are two failure, which is omission failure and arbitrary failure. Omission failure is cases when a process of communication channel fails to perform action that is supposed to do. And the second one, arbitrary failures, also called as Byzantines. Any type of failure may occur. Process may send wrong value of message content corrupted. The third one, failure in failure model is timing failure. No responses within a specified time for a synchronized system. The next one, failure is masking failure, which is knowledge of the failure characteristic of a component can enable a new service to be designed to make the failure of the components on which it depends. A service masks a failure either by hiding it or altogether or converting it into a more acceptable failure. Example, process cache can be masked by replacing the process and restoring its memory from information stored on disk by its predecessors. The last one is security model. Security model is the security of a distributed system can be achieved by securing the processes and the channels used for their interaction and by protecting the object that they encapsulate against unauthorized access. Identifies the possible threats to processes and communication channels in an open distributed system. Threats related to integrity and privacy. The next one is a major design issue. There are five. The first one is object model and naming scheme. The second is distributed coordination and followed by inter-process communication, distributed resources, and the last one is fault tolerance and security. That's all for us. Thank you very much.